So this is the situation that you start out with, is these intense interrelationships between human beings and plants require species-dense floral environments to get going. Now the situation, the reason there's a species-dense environment in Paramalaya, as it's called, is because two continents are colliding there, and the species from both sides are drifting and intermingling, so that in Malaysia, even though it's a small landmass, not a continental landmass, you get a very dense speciation. You see, all of Indonesia was once a continent called Sundaland, very recently, in fact, perhaps as recently as a couple of million years ago. And then with the rise of the sea, this continent was turned into a series of islands, and speciation proceeded on each island according to the constraints of that particular ecosystem. And with the rising and falling of the sea level and the islanding and reuniting of different land masses over several cycles of glacial melt, it acted as a pump for evolution, and you see a fantastic species density there as well. So for people interested in the ethnobotany of hallucinogens, this poses a problem, because the distribution of hallucinogens is very lopsided in favor of the New World. In other words, of 800,000, more or less, angiosperms that have been classified, only 20 or so are major hallucinogens, even though several thousand contain psychodynamic alkaloids of one sort or another. But the problems which interfere in their utilization range from low concentration to coincidental appearance with a toxic compound of some sort. This is why, and there are borderline cases, drugs where a hallucinogen will occur with a toxic or emetic compound, but has still been utilized culturally. For instance, morning glory seeds are a good example of that. The seeds of Ipomea purpura, which is a New World convolvulaceous climber, a morning glory, contain compounds which are related to LSD, but active in a magnitude larger dose. But also coincident with this compound occurs ester coumarin, which is a very strong emetic, makes you vomit. So folk utilization of these morning glories had to develop a way to separate these things out. And this is one of the issues that ethnobotanists have to grapple with, and students of culture generally, which is, how has it happened that these plant interactions have been discovered and utilized by people? And it isn't only plant interactions, it's strange dyeing, not only drug interactions, it's strange dyeing technologies for etching metal, technologies for curing wounds. How did they know what to do with each particular plant? For instance, a case about which we'll hear a lot this weekend, because I will talk about it, and tomorrow my brother will come in and talk about it as well, is this drug complex in South America called ayahuasca, where two plants are brought together, neither of which is particularly active by itself, but together they utilize the pharmacological principle of monoamine oxidase inhibition and create a powerful hallucinogen. So when you go into the field, you have to bear in mind the background geography, thank you, of the situation. For instance, the Amazon situation is unique on the planet The Amazon is the largest river in the world. It's estimated that 20 to 30% of the world's oxygen is being generated by those forests. And yet, the Amazon is a river which once flowed the opposite direction. Before the separation of the African and South American continent 220 million years ago, there was a river which rose in the mountains of Niger and flowed west across the vast expanse of what was then a portion of Gondwana land. Is that right? I think so. And it emptied into the Pacific Ocean. And then when the continents separated, there was subduction of the Nazca Plate under the South American continent, and the entire continent shifted very, very slightly. But because it was basically planar, this slight shift was enough to reverse the flow of the river. And then, of course, the Andes rose, and they're still rising. And so this ecological catastrophe, if you wish, looms very large in looking at the way species were distributed through the Amazon. Now, all these things went on long, long before the advent of man, but they explain the species distribution, the situation as human beings found it when they entered the New World. And when that happened, and the dates now are very controversial, with the most radical people saying that it was up to 2 million years ago, which is considered absolutely unsupportable by the mainstream anthropological opinion, which thinks, that a date of 60,000 years is very high. But whatever happened, it appears that people entered the Amazon both by the Caribbean islands, by a radiation which came down across North America, through Florida, through the Caribbean islands. There's one school that believes that Mexico was actually repopulated from the south, that the wave of migration was a great hook passing through the Caribbean and then up the Amazon. But there's very little data, so that there are many competing schools about the history of early man in the Amazon. The point of view I just stated is that of this geographer Donald Lathrop, who studied the languages in the basin and concluded that based on the way cognates proliferate, the languages must have been carried from the mouths of the rivers up to the headwaters. Previous to that, the anthropological theory that held was that large human populations could not arise in the rainforest, and that civilization in South America was largely a montane phenomenon. The Incas and the San Augustine cultures, and these cultures building always in the Andes, and that when people moved into the jungle, they essentially were subsumed and lost identifiable material culture, which is what the archaeologist is tracing these things by. Now it's not clear. Recent discoveries with side-ranging radar in the Yucatan showed that there, which is of course not South America but Mexico, but that there the Maya had very large areas under cultivation with systems of earthenwork dams and irrigation channels, which allowed them a much greater carrying capacity for their civilization than had previously been suggested for them. This same sort of thing may have existed in the Amazon, but the evidence for it may be much harder to come by, because the rivers are shifting so much, because the river changes its course so often. I mean, when you fly over the basin, you see rivers that cannot find their way, rivers that loop hundreds of miles back upon themselves, rivers that, as they meander on each side of them, there are hundreds of what are called oxbow lakes, which are essentially thrown out crescent-shaped arms of the river that have then been left. Because the Andes are a young mountain chain, earthquakes are frequent. I mean, I've not spent years in the Amazon, and I've experienced several earthquakes. And because the land is so flat, these slight earthquakes are actually driving river change in the course of the river, which reminds me of something else that I should mention, which is to return to the point about the evolution of dense species situations in plants. Before the advent of human beings as a cultural force on the planet, the major force, it's thought by evolutionary biologists, which drove plant evolution was the meandering of rivers. Because you see, the way evolution works is there is never much of it where there is a highly evolved and integrated ecosystem, because that is a set of interlocking niches, each of which is occupied. The place where evolution takes place is in so-called barren lands, where it's up for grabs, where whoever gets there first has the advantage. This is, and rivers, as they change their course, expose millions of acres every year of bank. And it is this contest for who shall occupy the bank that was, before the advent of man, the major force driving plant speciation. This is why we have weeds. If you look at what weeds are annular plants which produce thousands and thousands of seeds and which grow very readily. In other words, their strategy for survival is rapid growth and massive seed dispersal. This is a strategy which would only work in a barren land or open land situation. It would never work in a primary or climaxed ecosystem of any sort. Because the Amazon basin is the world's largest river system, it has that going for it too, driving the engine of evolution. So it is a continental landmass, which always means as the potential for plant and animal populations expands, there's always a greater potential for evolutionary drift. So that happens more on continents. And then it is equatorial. It's thought that evolution proceeds faster. Well, it's not that it's thought. It's obvious that evolution proceeds faster in the tropics because there can be continuous generations. For instance, in the butterflies or something like that, you don't get one brood a year. You can sometimes get up to 6. Well, each mating season constitutes an opportunity for gene transfer and for the appearance of new characteristics. So this is another factor, the equatorial situation of these continents, of the South American continent and the submerged continent of Indonesia, which presents itself now as an island chain. To return then to the human impact on the Amazon basin and the plant formation, though we cannot pick out the irrigation channeling that has been visible in Quintana Roo, it's probably because of the shifting nature of the river. Lathrop and his co-workers have found kitchen midden soil 1.5 meters deep in various parts of the basin, which indicates very long habitation and extreme sedentariness of the population. In other words, we're not dealing here apparently with hunting and gathering groups. To have kitchen midden soil 1.5 meters deep, people have to settle for several hundred years. It must mean that there's some kind of agriculture, perhaps aquaculture, something like that the North American Indians practiced with wild rices, this kind of thing.